Welcome to our latest video on the topic of quantitative chemistry. This video is on the subject of concentration and is suitable for GCSE students. By the end of this video lesson, you should be able to explain the meaning of the term concentration and understand that concentration is usually expressed in moles per decimeter cubed. You should also be able to convert concentrations expressed in moles per decimeter cube to grams per decimeter cube and concentrations expressed in grams per decimeter cube to moles per decimeter cube. And finally, you should be able to calculate concentrations of solutions in moles per decimeter cube from given masses of solute and volumes of solution. Now, in our previous videos on quantitative chemistry, we've discussed the concept of a mole. And we've seen previously that it's impossible for a scientist to weigh out one atom or one molecule of a substance because they have such a small mass. And in chemical reactions, we're dealing with huge numbers of particles reacting at any one time, so we use the term mole as a counting unit for particles. Now, there are 6.022 times 10 to the 23 atoms, molecules or ions in a mole. Now, that's a huge number. It's basically a 6 followed by 23 zeros. Now, this number is called Avogadro's number, or Avogadro's constant, after the Italian scientist Amedeo Avogadro, who discovered this number. Now, at GCSE, you'll never be asked to remember Avogadro's number, so you don't have to know that it's 6.022 times 10 to the 23. But you do have to understand the concept of a mole, the idea that a mole is a set number of atoms, molecules or ions. It's simply a counting unit that makes it easier when we're discussing the number of atoms, molecules or ions, because we're dealing with such big numbers in chemical reactions. Now, in our previous video on moles, we learnt that the number of moles of a substance can be calculated using the following formula. The number of moles is equal to the mass in grams divided by the molar mass, which is either the AR value if you're dealing with atoms or the MR value if you're dealing with molecules. So a mole is always 6.022 times 10 to the 23. But what changes is the molar mass, because the molar mass is how many grams you need to have a mole. And it's equal to the MR value when you're dealing with molecules or the AR value when you're dealing with atoms. Now, the MR value of water is 18. So if you have 18 grams of water, 18 grams divided by the molar mass, the MR value of 18, would give you a mole. So I need 18 grams of water to have 1 mole of water. And if I have 1 mole of water, I have 6.022 times 10 to the 23 molecules of water. Now, in this video, we're going to focus on concentration. And in chemistry, the concentration of a solution is the quantity of a solute that is contained in a particular quantity of solvent or solution. And concentration is usually expressed as the number of moles of a solute present in 1 decimeter cubed. Now, a decimeter cubed is equal to a litre, which is equal to 1,000 centimeters cubed of a solution. Now, concentration therefore has the units moles per decimeter cubed. And these units can also be written as moles dm to the minus 3, or simply as a capital M. Now, on this slide you can see 2 beakers containing solutions, and the solution on the left is at a higher concentration than the solution on the right. The solution on the left has more particles of a substance in a given volume than the solution on the right. And that's why we say it is at a higher concentration, because concentration is a measure of the quantity of a solute that is contained in a particular quantity of solvent or solution. Now, when doing any calculations in quantitative chemistry, you have to be familiar with moles, mass and molar mass. And we've seen in our previous videos that to convert mass to moles, we simply divide mass by the molar mass, the AR or MR value. And if we want to convert moles to mass in grams, we simply rearrange this formula to mass in grams equal to moles times molar mass, which is either the AR or MR value. So if we wanted to convert 2 moles of water, H2O, to its mass in grams, all we would do is do moles times molar mass The molar mass is the MR value of water, which is 18. So the mass in grams of 2 moles of water is 2 times the molar mass, 2 times 18, which would be 36 grams. And this formula triangle can be used to help you understand the relationship between moles mass and molar mass. Now, concentration can be expressed in moles per decimeter cubed or in grams per decimeter cubed. So sometimes in calculations you'll be presented with a concentration in grams per decimeter cubed, and you'll be asked to convert it to moles per decimeter cubed, or vice versa. Now, if you want to change concentration in grams per decimeter cubed and convert it to concentration in moles per decimeter cubed, we simply divide the concentration in grams per decimeter cubed by the molar mass, because mass divided by molar mass will be the number of moles. So to convert concentration in grams per decimeter cubed to moles per decimeter cubed, you simply divide by the molar mass, which is either the AR value or the MR value. Now, if you're given a concentration in moles per decimeter cubed and you have to change it to concentration in grams per decimeter cubed, you then simply multiply it by the molar mass, the AR or MR value, because to convert moles to mass, we always multiply by the molar mass. So we can express concentration as a mass concentration in grams per decimeter cubed, or in terms of a molar concentration in moles per decimeter cubed. It's more common for you to see concentration expressed in moles per decimeter cubed, and these units can also be written as moles dm to the minus 3, or simply as a capital M. And if you see a capital M, it stands for moles per decimeter cubed. So to test your understanding of this, we're going to do an example question. So if you'd like to have a go at the example question before I go through it, pause the video, read for the question and have a go at the question. But if not, you can fast forward to me going through the solution. So in these example questions, you're asked to first convert a sodium chloride solution concentration in moles per decimeter cubed to a concentration in grams per decimeter cubed. And then part B, you're asked to convert a hydrochloric acid solution concentration, which is in grams per decimeter cubed, to moles per decimeter cubed. So remember, mass is equal to moles times molar mass, and moles is equal to mass divided by molar mass. And the molar mass is either the AR value if you're dealing with atoms, or the MR value if you're dealing with molecules. So in question A, we have a sodium chloride solution which has a concentration of 0.5 moles per decimeter cubed, and we're asked to calculate its concentration in grams per decimeter cubed. So concentration in grams per decimeter cubed is equal to the concentration in moles per decimeter cubed, the moles, times the molar mass. And the molar mass here is the MR value of sodium chloride. So to work out the molar mass of sodium chloride, the MR value, we have to add up the AR values of all the atoms present in sodium chloride. So the MR is equal to 23 plus 35.5. So it has a value of 58.5. Now, the concentration in grams per decimeter cubed is equal to the concentration in moles per decimeter cubed, the moles, which is 0.5, times the molar mass, which is the MR value of 58.5. And if we put this into the calculator, we will get a value equal to 29.25, and therefore the concentration is 29.25 grams per dm cubed. Now for part B, we have a hydrochloric acid solution which has a mass concentration of 73 grams per decimeter cubed, and we're asked to calculate its concentration in moles per decimeter cubed. So remember, to convert mass to moles, we divide by the molar mass. So the concentration in moles per decimeter cubed is equal to the concentration in grams per decimeter cubed divided by the molar mass. Now the molar mass is simply the MR value of hydrochloric acid. So the MR of hydrochloric acid is simply the AR of hydrogen plus the AR of chlorine, which will be 1 plus 35.5, which will be equal to 36.5. So to work out the concentration in moles per decimeter cubed, we simply take the concentration in grams per decimeter cubed, which is 73 grams per decimeter cubed, and we divide it by the molar mass of HCl, which is the MR value, which is 36.5, and that will give us a concentration in moles per decimeter cubed equal to 2 moles per decimeter cubed. Now in the next section of this video, we're going to look at how you calculate the concentration of a solution given the mass of solute and the volume of solution. Now concentration is usually expressed as the number of moles of a solute present in 1 decimeter cubed of a solution, and 1 decimeter cubed is equal to a litre, which is equal to 1,000 millilitres, and a milliliter is the same volume as a centimetres cubed. So a decimeter cubed is equal to 1,000 centimeters cubed. Now solutions are very rarely made up in 1,000 centimeter cubed flasks. So it's important you can work out the number of moles present within a given volume and then scale it up to 1,000 centimeters cubed. And you can see in this picture that we have different size volumetric flasks here. We have a 50 centimeter cubed flask, we have a 100 centimeters cubed, we have a 250 centimeters cubed, a 500 centimeters cubed, and the 1,000 centimeters cubed flask. And it's very common for us to make up a solution in, say, a 50 or a 100 or a 250 centimeters cubed flask, and then you have to work out what the moles would be in 1,000 centimeters cubed. So you do this by just scaling it up, working out what it would be in, say, 100 or 250 centimeters cubed, and then working out how many 100 centimeters cubed are in 1,000 centimeters cubed and how many 250 centimeters cubed are in 1,000 centimeters cubed. So you just scale up the number of moles to work it out in 1,000 centimeters cubed. So now let's show you an example of this in practice. Imagine you're asked to work out the concentration in moles per decimeter cubed of a solution formed when 10 grams of sodium hydroxide is dissolved in a total volume of 250 centimeters cubed. So to do this, we first work out the moles of sodium hydroxide that we have in 10 grams. So moles is equal to the mass divided by the molar mass, and the molar mass is equal to the MR here of NaOH, and the MR of NaOH is equal to 23 plus 16 plus 1, so it's equal to 40. So we first work out the number of moles that we have if we have 10 grams of sodium hydroxide. So the moles of NaOH in 250 centimeters cubed would be 10 grams divided by the molar mass, which is 40 grams per mole, and the molar mass is the same as the MR value because we're dealing with a compound here. So the total moles will be 10 grams divided by 40 grams per mole, which will be equal to 0.25 moles, and that's the number of moles that you have of NaOH in 250 centimeters cubed of solution. Now all I have to do to work out the concentration here is just scale it up to 1,000. So if I have 0.25 moles in 250 centimeters cubed, I would have 4 lots of 0.25 in 1,000 centimeters cubed, because 250 centimeters cubed goes into 1,000 4 times. So all I have to do is do 0.25 times 4, and I will get the number of moles that I'd have in 1,000 centimeters cubed. And that would be the concentration, because concentration is just moles in 1,000. So therefore the concentration is 1 mole per decimeter cubed, because I would have 1 mole in 1,000 centimeters cubed, and a decimeter cubed is 1,000 centimeters cubed. So the concentration in moles per decimeter cubed is 1 mole per decimeter cubed. So when calculating concentrations of solutions, we always have to remember to work out the number of moles of solute present within a given volume of solution, and then work out what the moles would be if we had a volume of 1 decimeter cubed, 1,000 centimeters cubed. So as you can see here, what we did for this calculation was we worked out the number of moles of sodium hydroxide that was present in our 250 centimeters cubed solution. We did 10 divided by 40, the molar mass, the MR value of sodium hydroxide, and that was 0.25 moles. And then all we did was we worked out how many 250 centimeters cubed would go into 1,000 centimeters cubed, that would be 4, and we times the number of moles by 4. So when we times 0.25 moles by 4, we got a concentration of 1 mole per decimeter cubed. Now, 250 centimeters cubed going into 1,000 was very easy to work out. We could do this in our head. We worked out that it was 4 times and we needed to times the number of moles by 4. However, it might not be that easy if you're given different volumes that are not so easy to work out. So therefore, the following equation helps us to overcome this, because concentration in moles per decimeter cubed is simply the mass in grams divided by the molar mass, the AR or MR value, times 1,000 divided by the volume in centimeters cubed. So I like to think of this equation as the first part being working out the number of moles, the mass over the molar mass, which is the AR or the MR value, and then the second part is just the scaling factor, scaling it up to 1,000 centimeters cubed. So for example, if I had 100 centimeters cubed, 1,000 divided by 100 would be 10, so I times my moles by 10 to scale up my 100 centimeter cubed solution to 1,000 centimeter cubed solution. So that's how this equation works. So we're now going to test your understanding of this with some practice questions. So here are the first 2 practice questions. Read for the questions, pause the video, have a go at them, and then we'll go for the answers. So the first practice question is asking you to calculate the concentration in moles per decimeter cubed of the solution formed when 10 grams of potassium hydroxide, KOH, is dissolved in a total volume of 500 centimeters cubed. Now, to work out concentration in moles per decimeter cubed, we use the following equation. It's mass divided by molar mass times 1,000 over volume, and the molar mass is equal to the MR value here of KOH. So to work out the MR value of KOH, I simply add up the AR values for all the atoms present in KOH. So the AR value of potassium is 39, the AR value of oxygen is 16, and the AR value of hydrogen is 1. So that will give me an MR equal to 56, and therefore the molar mass will be 56 grams per mole. So to work out the concentration, I do mass over the molar mass, so 10 over 56, and I times it by 1,000 over the volume. Now the volume is given in the question, it's 500 centimeters cubed, so it'll be 10 over 56 times 1,000 over 500. So that will give me a concentration equal to 0.36 moles per decimeter cubed. Now another way to think about this is if I do 10 over 56, I get the moles present in 500 centimeters cubed, and then I'm effectively timesing it by 2 to work out its concentration, because concentration is moles in 1,000. Now question 2 is asking me to calculate the concentration in moles per decimeter cubed of the solution formed when 55 grams of calcium chloride is dissolved in a total volume of 100 centimeters cubed. So once again, to work out concentration, I do mass divided by molar mass times 1,000 over volume. The MR value of calcium chloride here is 40 plus 35.5 plus 35.5, which is 111. So therefore, I work out the moles, which is 55 divided by 111, and then I times it by 1,000 over the volume. Now my volume from the question is 100 centimeters cubed, so when I do 55 divided by 111 and I times it by 1,000 divided by 100, I get a concentration in moles per decimeter cubed of 4.95. Now once again, another way of looking at this is to work out the number of moles that I have in my 100 centimeter cube solution, and then I'm effectively timesing it by 10 to scale it up to 1,000. Because concentration is moles in 1,000 centimeters cubed or moles per decimeter cubed. So here's our last set of practice questions. Once again, read for the questions, pause the video, have a go at them, and then we'll go for the answers. So for question 3, we're asked to calculate the concentration in moles per decimeter cubed of the solution formed when 29.25 grams of sodium chloride, NaCl, is dissolved in a total volume of 1 decimeter cubed, and 1 decimeter cubed is equal to 1,000 centimeters cubed. So concentration is just moles in 1,000 centimeters cubed, moles in 1 decimeter cubed. So concentration is equal to mass divided by molar mass times 1,000 over volume. Now the MR of NaCl is 23 plus 35.5, so that's equal to 58.5. And concentration is equal to the mass, which in this case is 29.25, divided by the molar mass, the MR value here of 58.5, and I times it by 1,000 divided by my volume. Now my volume is given in the question, it's 1 dm cubed, which is 1,000 centimeters cubed, so it'll just be 1,000 divided by 1,000. So my concentration will simply be 0.5 moles per decimeter cubed. Now another way of looking at this is I work out the moles present by just doing mass over MR, or mass over molar mass, and then I scale it up to 1,000. In this case I don't need to scale it up to 1,000 because the volume is already 1,000. So the concentration was simply just working out the moles and then expressing it in moles per decimeter cubed. So for question 4, we're asked to calculate the concentration in moles per decimeter cubed of the solution formed when 12 grams of sodium carbonate, Na2CO3, is dissolved in a total volume of 250 centimeters cubed. So concentration is equal to mass divided by molar mass times 1,000 over volume, and the MR of Na2CO3 is equal to 23 plus 23 plus 12 plus 3 lots of 16. So that will give us an MR value of 106, and that is equal to the molar mass here, because the molar mass is equal to the MR value. So concentration is equal to the mass, which is 12 grams, divided by the molar mass, which is 106, times 1,000, divided by the volume, which we get in the question, which is 250. So if we do 12 divided by 106, and we times it by 1,000 over 250, and we put these numbers into the calculator, we will get a value for the concentration of sodium carbonate in moles per decimeter cubed. So this comes to be 0.45 moles per decimeter cubed, and that is our concentration. Now again, another way of looking at this is we work out the number of moles in 250 centimeters cubed by doing 12 over 106, and then we scale up the 250 centimeters cubed to 1,000 centimeters cubed to express concentration. So we're effectively times it by 4. So that concludes this video lesson. So after watching this video, you should now be able to explain the meaning of the term concentration and understand that concentration is usually expressed in moles per decimeter cubed. You should also be able to convert concentrations expressed in moles per decimeter cubed to grams per decimeter cubed, and concentrations expressed in grams per decimeter cubed to moles per decimeter cubed. And finally, you should be able to calculate concentrations of solutions in moles per decimeter cubed from given masses of solute and volumes of solution. So that concludes our video. Please check out our YouTube channel, Dr. O Chemistry, and our Twitter site, which contains lots of chemistry information and links, @RadaChemistry.